Hello everyone. Today we are going to learn some switch topics like DTP protocol, dynamic trunking protocol, and I'm going to tell you about. But before DTP, we will be discussing about access and trunk ports. Then I'm going to tell you about DTP. After DTP, we will be discussing native VLAN, or what we are going to do is we will cover native VLAN before DTP. Then we will be covering sub interfaces. One topic is this is one of the important topics. Sub interfaces, you must know about router on a stick concept. Router on a stick, right? So these are some of the topics which we are going to cover today. What is difference in between trunk and access port? You must have studied it in CCNA. Now let me tell you. Let's say if we want only one VLAN traffic to be forwarded from switch port. Let's say this is our switch 1 and this is our switch number 2. If we want only one VLAN traffic to be forwarded from this port, then we will make this port as access port. Now, what is the command to make a port access? Let's say this port number is in global configuration mode. The port number will be interface fast Ethernet 0 by 1. I'll enter the command switch port mode access. After that, in the same interface, I'll enter second command switch port access VLAN number. Let's say it's in VLAN 10, right? So VLAN 10 traffic will be forwarded from this interface. Apart from it, no other VLAN traffic can be forwarded from access port. I think I have covered these commands in previous videos. You can check them out from the previous videos. Now, let's say if I want to make a port trunk, why I'm going to make a port trunk? If we want, I'll write it down here. If we want to send multiple VLAN traffic from the port, then interface will be made. Interface will be made as trunk port, right? Now, if I want to make a port trunk manually, I can do it with the help of command. Now, what will be the command? Let's say if I want to make port number fast Ethernet 0 by 1 as trunk, I'll enter the command switch port mode trunk. But before this command, you will have to enter the encapsulation. The command for encapsulation will be switch port trunk encapsulation dot 1Q. Now, uh, the encapsulation is used in trunk port so that the switch can add the VLAN number when sending the traffic from the port. Let's take an example. See, we have one switch and we have made the interface in between these switches as trunk, right? Now, I want to send a traffic of VLAN 10 and traffic of VLAN 20 from the same port. I'll mark it as VLAN 10 and VLAN 20. We will make this port trunk, but how will receiver or the receiving switch understand that this traffic is related to VLAN 10 or this traffic is related to VLAN 20? It will be done with the help of encapsulation. In the Ethernet header, what will happen is switch 1 will forward this traffic from trunk port, but it will do encapsulation. Which encapsulation this switch 1 will use? It will be using dot 1 queue. And in dot 1 queue, 4 bytes of extra traffic is added. So this will be extra traffic which will be added in the Ethernet header. Now let me remind you, this is Ethernet header, right? Dot one queue header is divided into two parts. If I'll draw it here, let's say this is dot one queue, it will be divided into two equal half. The first one will be known as TCI and the second one will be known as TPI, right? 4 bytes. This will be of 2 bytes and this will be of 2 bytes. The name of this field will be TCI and the name of second field will be TPI. Now TCI and TPI stands for TCI stands for tag control identifier. TPI stands for tag. It stands for tag protocol identifier. And it is not tag control identifier, it is tag control information. So one of these fields will contain VLANs, right? VLANs are from range 0 to 4095, right? Which is equivalent to 2 to the power 12. So there are 12 bits which will be used for VLANs. You can easily see that 2 bytes is equals to 16 bits. So my VLAN information can come in this header. So this is how encapsulation will be done on trunk ports, and we can make an interface trunk with the help of these commands, right? After that, once you have made the interface trunk, you can enter or you can see that there is a concept of native VLAN. What is this native VLAN? Let's understand it with an example. I'll take the same example. We will take two switches. These are two switches. Now the interface in between these switches are or is trunk, right? This interface is trunk. Now what will happen is if a traffic is forwarded from this switch, if a tagged traffic is forwarded, encapsulation will be done, VLAN information will be added like VLAN number 10 and VLAN number 20. So these will be the tagged traffic which have the VLAN information in it. Let me note it down. This is known as tagged traffic. Now, if we want a traffic to be forwarded from trunk link as untagged, right? As untagged, which means that there will be no VLAN information in this traffic. This untagged traffic from trunk link can be forwarded with the help of which VLAN? Native VLAN. So I'm going to note it down. The untagged traffic can be forwarded through native VLAN. Done on, but you must remember on which port we are talking. It is the trunk port. There will be no use of native VLAN on the access ports. Now let's do it with the help of an example. Let's understand it with the help of an example. In Cisco Packet Tracer, I'll take two switches and I'll make the interface as trunk. Let's take these two switches. I'll connect these two switches. I'll make this interface fast Ethernet 0 by 1 as trunk. This is switch number 1. Enable global configuration mode, interface, fast Ethernet, 0 by 0, not 0 by 0, 0 by 1, switch port mode, trunk. Now, I am not going to enter the encapsulation command. Reason is that in Cisco switches now only 802.1q encapsulation is used by default, so you do not need to mention it. But in some of the Cisco switches, you will have to give the encapsulation command, this one. Else it will not take switch mode trunk. After that, once I have made this interface trunk, I'll go to another switch. No, we are not going to switch to right now. Let's see if 0 by 1 is made trunk or not, how we can check it. First of all, interface, show interfaces trunk command. Show interfaces trunk command will tell me that port number 0 by 1 is enabled for trunking. See, the status is trunking. Encapsulation used is 802.1q. And what is the mode? It is on because we have manually or statically created trunk on this interface 0 by 1. After that, what is native VLAN? Native VLAN will always be VLAN number 1 by default. By default, it is VLAN number 1. Now, that means from VLAN 1 only, the untagged traffic will be forwarded. We can also change native VLAN, but we will do it later. After that, if you want more information regarding this port, trunk port, you will enter the command show interface fast Ethernet 0 by 1 switch port. See, in this command, fast Ethernet 0 by 1, it is showing me administrative mode as trunk. Native VLAN for this interface is 0 by 1 and encapsulation used is .1q, right? So all the trunk information for an interface can be seen with the help of command show interface fast Ethernet 0 by 1. After that, now I'll go to switch 2. I have not configured any trunk on switch 2 enable, but when I'll run the command show interfaces trunk, we can see that in show interfaces trunk, port number 0 by 1 is trunk, mode is showing auto. I'll come to this part, and 802.1q encapsulation is used. Here N stands for negotiation, status is trunking, native VLAN is VLAN number 1. That means it means that once we have configured switch 1 as trunk, manual trunk, automatically the other end of this cable or switch to interface will automatically become trunk, right? After that, let's say if I am going to change native VLAN on switch 1, let's do it. How we can change native VLAN? In global configuration mode, interface fast Ethernet 0 by 1, switch port trunk native VLAN will be, let's say I'm saying native VLAN is 10. Now, we can change native VLAN. For example, on this switch, the native VLAN is 10, for which interface fast Ethernet 0 by 1. And by default for switch to 0 by the native VLAN is 1. Done. In this scenario, what will happen is in this scenario, the interface will remain up. You can see that the ports are up. I can show you with the help of command do show interface, do show IP interface, brief. See, 0 by 1 is up, right? But switch will give you a console message and it says that CDP native VLAN mismatch. After that, native VLAN mismatch discovered on fast Ethernet 0 by 1. For us, it is VLAN number 10, and for other switch, interface 0 by 1 native VLAN is 1. That means the interface will remain up, but the switch will continuously pop up this message. So once you see these messages, what you have to do is you will have to check the native VLAN and then you have to change it. How you can check the native VLAN? I just told you the command. Show interface fast Ethernet 0 by 1 switch port. See, what is trunking native VLAN on this switch? VLAN number 10, which is inactive right now. We have to change it to VLAN number 1. That means we have to match the native VLAN on the trunk port. Both ends of the switches must have same native VLAN. Done. After this, once we have understood access ports and trunk ports, native VLANs, I'll come to DTP. Now, DTP stands for Dynamic Trunking Protocol. Dynamic Trunking Protocol, basics about it, it is a layer 2 protocol, right? It is Cisco proprietary and it is used to make the link as trunk in between switches. If I want to make the links trunk in between switches, then we will use DTP. Now, trunk link, how it will be made? It is dynamic trunk. What do you mean by dynamic trunk? It means that in between these two switches, now DTP message will be forwarded. What will happen is DTP messages will be forwarded in between these two switches so that the link can be made as trunk link. How? Let me show you. So basically in DTP there are two modes of the interface, dynamic, auto, and the second one is dynamic desirable. Now, dynamic auto and dynamic desirable, there can be two modes only in DTP. By default, DTP is enabled on Cisco switches, right? After this, if one of the end is dynamic desirable means that DTP messages will be initiated. So from the dynamic desirable end, DTP message will be forwarded and the link will become trunk. If both the ends are dynamic desirable, now DD, I'll represent dynamic desirable by DD. In dynamic desirable, if both the ends are dynamic desirable of these switches, then also the interface will be trunk. But if both the ends are dynamic auto, in this case, the switches will not, the interface will not become trunk. So we have to make sure if we want the TP to be enabled, we will make one of the interface as dynamic desirable, then interface on both the ends will be trunk. Now let's see practically if we can do it. On first interface, I'll enter the command interface fast Ethernet 0 by 1 switch port trunk native VLAN. Let's make it 1 shutdown, no shutdown, switch port mode. This time I'll not use trunk. I'll use dynamic desirable or dynamic access. We have to make it dynamic desirable. Then I'll enter dynamic desirable. See, now still fast Ethernet 0 by 1 will be dynamic desirable. Do show interfaces trunk. This is dynamic desirable. Status is trunking. But right now you are not seeing the mode is on. It will be desirable. Another end of the switch will be dynamic auto. See, we could see it. It is dynamic auto. Still, it is in trunk mode. So this is how DTP can be used to make an interface trunk, but nowadays you might not encounter this in real-time environment. Now, one question which can be encountered in interviews is, let's say I have two switches. Native VLAN is different on both the switches, right? How will switch 1 come to know that the native VLAN is different on switch number 2, right? How will switch 1 recognize the native VLAN of switch number 2? It is very easy. The answer is CDP. Cisco Discovery Protocol is running in between these switches, and in that CDP message, native VLAN is exchanged in between switches. So this is how one switch will come to know about the native VLAN of another switch. Now, what is the use of Cisco Discovery Protocol CDP? We will learn it further in other sessions. Now let's have a look towards the messages of DTP. How we can see the messages of DTP in Cisco Packet Tracer? It's very easy. From real time, we will move to simulation mode. I'll select edit filter and I'll choose DTP. In miscellaneous, see, DTP is there, right? I have chosen DTP. After this, I'll just click on capture and forward. You can see a red packet is transmitted from switch 2 towards switch 1. Let's open up this packet. Inbound PDU says that this is a DTP traffic, right? Now, DTP type, what it is showing? Trunk, right? So this is how DTP messages will be exchanged from one switch to another switch, and link will become trunk, and it is layer 2 protocol, right? It is encapsulated in LLC, or you can say Ethernet header. We can also see CDP packets over here, and we will try to find the native VLANs in that CDP packet. What I'll do is I'll again click on the simulation mode, but this time we will use CDP. We will filter out CDP packets. Then what I'll do is I'll click on capture and forward. We can see a blue color packet. I'll open it, and in this CDP packet, if we can, it would be great if we will be able to see the native VLAN, but right now I don't think we will be able to see it. Let's try to capture another packet. I don't think we will be able to capture it over here. We will another time we will capture it in the Cisco, not in Cisco Packet Tracer, in the Wireshark, and then I'll show you. Now the next question is, how can we disable DTP on interface? How can we disable DTP on interface? It is very simple. First of all, you will make the interface as trunk. Manual trunk must be made. So command will be interface fast Ethernet 0 by 1. In that interface mode, you will enter command switch port mode trunk. Then in that same interface mode, you will enter switch port no negotiate. Let's see if we can do it. This is the same interface 0 by 1. Interface fast Ethernet 0 by 1. Switch port mode trunk. I have made it manual trunk. Switch port no negotiate. Right? So this is how we will disable trunk on an interface. Not trunk, we will disable DTP on an interface of a switch. Now I'm going to make a chart to show you when an interface will be trunk according to the modes of that interface. Interface can be dynamic desirable, not dynamic desirable, it is in on mode, manual trunk, dynamic desirable, and dynamic auto. on mode on the another end, dynamic desirable and dynamic auto. So if both the ends of the switch is on, then definitely the switch port will be trunk. On dynamic desirable, it will also be trunk. On dynamic auto, one end is on in on mode and another is dynamic desirable. This will also be trunk. Trunk, dynamic desirable on both ends. Trunk, dynamic auto, same trunk link. Trunk link, if one end is on mode and another is dynamic desirable. Trunk link, if one end is DD. Only one situation will be there when the interface will be non-trunk. It will be dynamic access, sorry, dynamic auto on both the ends. This will be non-trunk. So this, you must remember this when using DTP. Now everyone, let's discuss about the sub interfaces and why they are used. Before that, let me give you a scenario. Let's say I have a switch, two PCs are connected with this switch, but the interfaces are in different VLANs. Let's say this interface is in VLAN number 10 and this interface is in VLAN number 20. This one is PC1, this one is PC2. IP addresses are 10.0.0.1 slash 8 and the IP address on PC2 is 20.0.0.1 slash 8. Now, the default gateways must also be on the PCs. The default gateway of PC1 is 10.0.0.10 and the default gateway of PC2 is 20.0.0.10. So you must be clear with the concept of default gateway. Now I want PC1 to communicate or send traffic towards PC number 2. But problem over here is that switch will not forward VLAN 10 traffic towards this interface. It will never do this. If we want communication to be done, we will have to use inter VLAN routing. Inter VLAN routing. Now, what does this mean? It means that in between VLANs, we are going to route the traffic. How we are going to do it? When routing word will come, always a router will be or layer 3 switch will be introduced. So I'll have to attach a router with this switch. This one is router number 1. But the problem over here is that this one is only single interface. I have only single interface on this router. I can either give 10.0.0.10 or I can give 20.0.0.10, right? Only one physical interface is available, but we have two default gateways. Now, how can I resolve this problem? It is very easy. I can use the concept known as router on a stick. As you can see that as you can see that router 1 interface, there is only one interface which is connected to a switch and it is known as router on a stick. Now the next thing is that how does router on a stick works? It works with the help of sub interfaces. What does it mean? It means that this physical interface fast Ethernet 0 by 0, I will make sub interface of this physical interface. How we can do that? It's very easy. I'll enter the command in global configuration mode. I'll enter interface fast Ethernet 0 by 0 dot. I can use any number after it. When I'll enter it, my sub interface will be made and it will be dot 10. IP address, I can give IP address 10.0.0.10 255.0.0.0. But in this scenario, one problem is there. We need to define the encapsulation before giving the IP address to the interface. So what I'm going to do is I'm going to give the encapsulation command. Encapsulation dot 1q VLAN is 10. Similarly, I'll create one more sub interface for 20.10 and this time it will be dot 20. You can take any number. I am taking VLAN number over here. So you can take any number. Now encapsulation dot one Q, it will be 20. IP address will be 20.10. So this is how two sub interfaces will be made for each network, right? And this interface of switch will be always trunk because according to the switch or the PCs, VLAN 10 traffic will be forwarded and VLAN 20 traffic will also be forwarded. So this interface have to be trunk link, right? Let's do a practical for this. What I'm going to do is I'll run these run this on real time. I'll take 2811 series router, then I'll take a switch. After this, we will take two PCs and I'll connect them, right? IP addresses, PC1 will have IP address 10.1, PC1 will have default gateway 10.10. Now to communicate in between different network, we need default gateway on PC. You must know about it. PC2 will have IP address 20.1 and 20.10 will be the default gateway. After this, what will happen is we are going to switch one and we will first of all create VLANs. How we can create VLANs? VLAN number 10, exit, VLAN number 20, exit. Interface fast Ethernet 0 by 1, switch port mode access, switch port access VLAN number 10. And another interface is 0 by 2, switch port access VLAN number, it will be in VLAN number 20. Done. 0 by 1, I have put this interface in VLAN 10. 0 by 2, I have put this interface in VLAN 20. Right? After this, sorry. After this, 0 by 3 will be made trunk link. Interface, fast Ethernet 0 by 3, switch port, mode trunk. Done. I have configured all the interfaces of the switch. I'll move on to router number 1. First of all, enable global configuration mode. Interface fast Ethernet 0 by 0, no shutdown. First of all, we will bring the physical interface up, right? After that, we will make sub interfaces. The command will be interface fast Ethernet 0 by 0 dot 10. Encapsulation dot 1Q VLAN 10 IP address 10.0.0.10 255.0.0.0 exit. Another sub interface will be encapsulation dot 1Q. It will be 20, not 10, and IP address will be 20.10. So I have made sub interfaces on this router. Let's check do show IP interface brief. In this command, you can see physical interface is up, but no IP address is assigned to physical interface. Sub interfaces have the IP addresses and they are also up. We can also check the routing table. Do show IP route. See, 10 and 20 network is directly connected with which interface? Sub interfaces. So this is how we can make two devices communicate in different VLANs. 20.1. Let's ping from PC1 towards PC2. Few packets may drop in starting, but after that, ping will be successful. See. So I'm sure you are, sorry. Yeah, so I'm sure you are done with this inter-VLAN routing or sub interfaces. Just always remember that sub interfaces are made so that we can communicate from one VLAN to different VLAN. Sub interfaces can be made on routers, not on switches. The switch interface which is connected with the router will be made as trunk. First thing you need to remember. Second thing which you need to remember is the physical interface will always be up. You cannot put the physical interface down and then when you will make sub interfaces, they will also be down. Always make sure to bring the physical interface up. After that, always check the interfaces of the PCs. The switch interfaces are in appropriate VLAN or not. So this is the concept of inter VLAN routing or router on a stick or sub interfaces. It is one of the important topics for CCA also because you have to create a logical topology from physical topology, which we will be discussing in further sessions. Thank you.